My name is Susanna Kass. I came here from the Bay Area, Silicon Valley to be specific. I spent 30 years in the IT industry, working with companies such as Hewlett-Packard, Sun Microsystems, and I was the COO for eBay International 16 years ago. So in the last 11 years or whatnot, I've been spending my majority of my time servicing clients. Absolutely have the pleasure to actually work with David's company and also Daniel's company. Learning a lot in terms of how we can actually improve the data center reliability, performance. So I'm a quantitative gal, graduate from Stanford, and I'm also a co-lecturer there at the moment right now in School of Engineering. So I have a passion towards data. So later on, maybe I can expand a little bit more about my interest there and what are some of the things that we do from a journey perspective inside the data center and also outside. So glad to be here.
You kind of said your bit before, didn't you, David?
Yeah, my background is machine learning, so I actually studied AI at university back in kind of 1990 something, and I chose it quite deliberately because at the time it was free to go to university in the UK. Because the government paid for it. So I thought it would be excellent to choose a subject which had absolutely no practical value in the world whatsoever and make the government pay for it, and my parents consequently. And unfortunately, GPUs existed, and then suddenly all the stuff that I learned at school suddenly became useful. So thus ruining my grand plan of never having to speak about AI.
Right. Okay. And so, Matt, you're...
Yep, I'm Matt Provo. I'm the founder of a company called Carbon Relay. I started my career in computer science and math, worked for a long time at Apple, about 10 years there, was responsible for helping a number of acquisitions come into the company and building products. I knew I wanted to start my own company, so I was fortunate enough to go back to grad school. So I attended Harvard for business school, and towards the tail end, knew that I wanted to build an AI company that actually was connected to real value and was solving real problems, as opposed to sort of a marketing budget with nothing under the hood, to a certain extent. I'm going to align with your controversial statements.
Yeah, you have to ask me later about my LinkedIn post yesterday on that subject.
So we've been in operation. We've been a company since 2015. Operating really in stealth mode completely until this year, actually, and we're starting to talk about what we're up to. And our focus is in the nascent part of AI called reinforcement learning. And so what we do is we are able to train a digital agent to navigate physical environments and be able to make automatic decisions and take actions without really any human intervention. We also build high levels. We really care about the safety component of AI. So we provide the ability for our users to define what autonomy means for them in their environment. If there's certain decisions or things that the user wants to retain control over, they're able to define that in advance or in real time. And at all times, they can certainly intervene and take control back from the AI agent. So we operate in data centers. We're thinking a lot around on the DevOps side of things. So in the IT infrastructure world, we're also thinking and operating in the power management and energy management, or what we would call energy optimization space.
Right. And Daniel, sorry to leave you to last, but someone had to be.
Yes. So my name is Daniel Akenine. I work as something called a National Technology Officer for Microsoft. So, which basically means I'm working for the Microsoft Technology Office, trying to understand what's happening in the world. So we're looking a lot of what kind of technology trends is happening in different areas in the world, what kind of tech policy is happening around the world as well, because it's very different, also in Europe, actually. So I'm based here in Stockholm. I'm Swedish. And I'm also responsible for security and cybersecurity at Microsoft in Sweden. I think I started focusing on AI more deeply. It was 1.5 to 2 years ago. And not necessarily on the hardware or the deep learning stuff. I was more focused on the social impacts of AI. So what happens to all of the other, not usual suspects on the table? For people like architects, or if you're a dentist, how is AI going to affect your work? So I was one of the co-founders of an organization called Add AI, which is based here in Stockholm, that is trying to understand more of the impact of AI in society, from a legal perspective, from an architect's perspective, et cetera, et cetera. So that's my main focus, at least for the last year.
Okay, I think first it's probably worth. My next question is going to be something along the lines of what is AI and does it matter? So, but first of all, from the audience, hands up if you personally have a clear idea of what AI is. Don't be yes, good. I'm glad someone's honest there, but nobody much else does. And we have a graduate in AI here. So I'm going to ask you to start.
So AI is much older than people expect it to be, right? So a lot of people have heard about it quite recently, but actually AI systems have been around for a long time. So you'll probably be familiar with things like expert systems. So these are, if the patient is blue and they're not breathing, they might be dead, try and restart their heart, right? So this was the kind of genesis of AI systems. They work, they're great, you should use them. If you can avoid using deep learning, I fully recommend that you go down the path of using an expert system. It has the benefit of being deterministic, and I can code it. So that's excellent, generally. The thing that I think probably most of the folk in the room and most of the folk here are kind of more excited about is a subset of AI, which is machine learning, and within machine learning, a subset of machine learning, which is called deep learning. And deep learning really is a way of managing stats, managing big pools of numbers, right? It's about drawing relationships between big pools of numbers, potentially disconnected data points, or systems which have complex interrelations behind them, generally quite dynamic systems. And what those machine learning models allow you to do is, without the computer, in a sense, having a real understanding of what it is that it's providing a model of, you can often provide an accurate simulation effectively of some physical system, and you can capture the essence of that physical system in what basically looks like kind of really simple. It looks like a kind of, we used to look at it at university, it's perceptrons we used to call them, but they're kind of models of neurons, right? So a neuron in your brain has a bunch of things that connect to it. It has some effectively signal processor. It's looking for some threshold of signals, and then it connects to a bunch more neurons. And in a machine learning system, that's just represented by very basic kind of component pieces. They have numbers, they have inputs, they have outputs. If a particular input reaches a particular threshold, then produce some output. And it turns out that with just that simple piece of stuff, you can do some really, really cool things. So the stuff that does that is the same that does cat recognition in photographs. It's fundamentally exactly the same kinds of networks that are able to distinguish cats from trees and elephants in photographs, that can also do things like make predictions about PUEs in data centers. Where the inputs aren't pixels, they become speeds of pumps and flows of water and temperatures outside. Then those same networks can produce kind of really meaningful predictions about how systems function, but without having an understanding of the underlying complexity of that system. And that's really cool, because modeling physical systems is really tough. And mostly modeling physical systems is tough because how deep do you do your model, right? So at some point in time you say, do I want to model every single atom that flows inside a pipe? I probably don't want to do that. Then do I assume that my flow is laminar or turbulent? You have all these complexities of these systems, and you build physical models, you simplify your physical models so you can run them in real time, and you find that they don't work. And what it turns out is that deep learning provides sometimes, in the right hands, provides a mechanism by which the complexities of those physical systems can be captured by a fairly simple, rudimentary piece of computing software, effectively.
And basically what's happened since you were studying it is that it used to be a theoretical thing you could model on big computers and
yes.
never
So
get
basically,
a
unless you
result
were the
from.
military, no one had the computing power to do it. So you could see that this stuff worked, right? A monkey could grind the wheel, and 6 months later you'd get a calculation, and you go, oh, it's a cat, but the cat's gone now, so it's kind of an irrelevant piece of calculation. And what happened was some clever graduate student realised that the way graphics cards effectively shade, so when you're trying to project some graphics on a screen, you've got these things called shaders, which allow you to kind of add effects and smoke and all these fun things in graphics. And it turned out that those simple things called shaders could also represent perceptrons. And so you had £100, $100 graphics cards that were suddenly capable of doing the kind of machine learning that you would have had to spend hundreds of millions of dollars on supercomputers before. So it's all his fault.
Right. Okay. And that led on to the possibility of doing what you're doing. It's what we're talking about when we're talking about using AI for this job or that job. To what extent is that really AI? To what extent is it just sort of something that doesn't really count as AI? Or should we not get hung up on that question?
So I would say there is really no super good definition of AI, which is both the strength and the weakness, actually. So I think one thing is that people today is using the AI, the headline for more or less everything. So we are seeing an enormous amount of AIification of a lot of applications. And what people are talking about when they talk about AI today, most people, is actually basically digitalization. So they used to use the word digitalization, but that's not a hype anymore. So you're going to the next hype, but they're basically talking about the same thing. And that's a problem actually for AI because it's not, people get in the end, people get bored and they feel, does this guy really know what he's talking about and blah, blah, blah. So it's, but it's a strength because things get hyped if it's a little bit unclear what they are. Because then you can actually talk about it in a broader context. So.
Yeah, this tendency to hype thing does burn out the buzzwords. And the blame for that lies with journalists like me, and we then blame the readers for demanding novelty. So, because
there's real companies doing real AI, though. This is real, right?
We have real AI here. Although I did kind of start to think at one point, some of the stuff you're talking about is some of the stuff that people used to talk about when they used to use the term big data.
Well, the field of AI is obviously vast. That's one of the reasons that it's difficult to understand exactly a true definition of AI, and I think the field is very dynamic. There's a ton of stuff still coming out of academia that's moving into the real world. One of the most difficult challenges, of course, is understanding what is my actual problem or problems that I'm trying to solve, and therefore, within the vast field of AI, what is the right approach in order to solve this particular problem? And I think a lot of companies who decide that they have a digital transformation strategy, they have an AI-first strategy now, end up coming to a place where there's not enough patience to walk a process forward. And what ends up happening is you essentially either build an internal or you contract out through vendors a strategy that ends up actually being a mile wide and an inch deep, or a kilometer wide and a centimeter deep in Europe. And we don't actually pick the right strategy to solve the problems that we're going after. So what we've tried to do from the outset is say, what are some of the largest blockers towards actually building true solutions that would both directly map to ROI, as well as continue to make my organization more efficient, reliable, et cetera. And I think on the front end, one thing we saw really clearly, especially in the enterprise AI world, is this idea and this requirement of having a year's worth of finely labeled, perfectly orchestrated data in place, right, before any sort of action could be taken. Right, so that's on the front end. So for us, in the example of energy optimization, part of our IP is that we've completely automated the process of what some of you may have done, which is bring in a set of people who are building an actual energy model of the building or the facility. We take the blueprints of the facility and a couple other files related to the actual physical space, and the agent itself automates the entire creation of a dynamic energy model. And this happens continuously as the thermal dynamics or the IoT instrumentation or the layout of the floor change. And we're able to do that because in this case we chose the right approach, which is a reinforcement learning first approach. And so that allowed us to reduce the barrier to entry on data capture, data acquisition in advance. And so I think what I would say around this approach or this idea of using AI inside of a data center or outside is it's very, very important that you take the time up front to understand the set of problems you're trying to solve, and therefore the right approach within the field of AI. And I think that if you do that appropriately ahead of time, and it's of course not perfect, but if you do that ahead of time, you can save yourself a whole lot of time downstream on approaches, coming to a dead end. And so we've tried to do that from the outset. We're not a DSIM solution. We're not an IoT solution. We're not a cooling solution. What we want to be is an intelligence layer that intuitively plugs into all of those. So we've got partnerships with a number of the big players in those categorical areas. And all we're trying to do is add a software component, an intelligent agent component that's compatible with all these things, that's built very intuitively to solve a specific set of problems.
Okay, so to make it work, it's all about making sure that you're collecting a lot of data, but before you do that, you've got to decide to collect the right data.
Oh, that's such a dangerous one. The data is...
Yeah.
I'm sure everyone on the panel's got an amusing story about how data can go wrong. So the kind of thing you have to keep in mind with the machine is a machine, so it has no common sense, right? And the training data really is what builds the model. So I'll give you an example. This is from uni. So once upon a time, a government that shall have to remain nameless was trying to use image recognition to detect tracked vehicles in photographs, satellite photographs. So you can imagine why that might be useful. And so the British Army provided a whole bunch of training data. I think I've probably given some of this away more than I intended to my old university. And we used it to build this fantastic system that was kind of like 96% degree of accuracy, could find armoured vehicles in photographs that were camouflaged, which was just fantastic at the time. It was just way better than analysts could do, and it could fly through these things. Problem was, it turned out what they did, and it makes kind of sense this, they drove all the vehicles into a field in the morning, hid them under trees, had all these troops running around hiding stuff. And then they moved them out and took a photo, moved them out in the afternoon, took another photo, right? So we built this fantastic system that was capable of detecting morning and afternoon. Because that's all it did. It wasn't actually detecting armoured vehicles at all. It was just the training photos had been poorly categorised, and so actually all it was doing was, in the end, no one really knows. You can't ask the machine.
If the shadows are there...
Yeah, no, so it actually had nothing to do with it.
So if the shadows are there,
that's the thing, because you can't tell the machine to just capture this specific piece of knowledge.
Yes.
So what it's looking for is patterns, right? So this is the kind of, we didn't miss patterns. AI is really about pattern recognition. And you have to be very careful about what the training data is so that you're not training on the wrong patterns. And exactly right, probably what this system was doing was looking at shadows. But it had nothing to do with the vehicles being in the photos or not, which we subsequently discovered when we did photos taken the other way around, which didn't work at all.
Right. Okay. Yeah, I mean, that illuminates to me the idea that an AI will find things in the data, possibly new physical relationships that weren't understood before, but it might find things that are just
wrong,
poor.
Yeah, and that can be a quality of data issue, it can be a quality of training data issue, it can be a quality of machine learning, it can be the wrong choice of machine learning. There's a whole bunch of reasons that can cause that, but certainly it's you talked about the data, and I think it's a big one. I'm sure Stanford are thinking about this stuff as well.
Anything like this happening at Stanford that you're aware of?
Well, I guess the setting that I'm involved in, artificial intelligence, may be a little bit different in the academic setting. It's more purposeful, and we define what it actually can do and cannot do. So some of the experience that maybe I can share with you all that I like to enable you all to be able to encourage to actually take some AI projects that you can think about how can actually help you after today's session. So my experience basically working with artificial intelligence is we identify areas and scope, we narrow it down, we constrain what we fundamentally believe that is actually possible to teach machine to learn from the experience that we can gain from that. So one of the rule of thumb that we actually focus on is the concept we use called supervised learning. If there are certain things within a few seconds you can actually detect, using David's example, that a few seconds you can actually detect if there's actually a car next to you while you're actually driving. So specifically right now in the Bay Area, there was a lot of attention paying attention to autonomous driving or self-driving. And so one of the key things that we can do is we felt that artificial intelligence or machine learning is actually a very good application for being able to detect whether you know there's actually a car next to you or not, because you can figure it out in a couple of seconds. So why bother to have a human to do that? And we can actually basically identify a set of training set. So data is important, but don't be misconstrued. You actually don't need big data to actually use that artificial intelligence. We actually find a certain degree of accuracy, which is actually fairly high, when you actually can do a proper labeling of the data. So we call that the training set. And then another data set that we felt is important, we call it the test data, which is then verifying the algorithm that you're actually going to create your own, which can be proprietary to you. Or actually, there's actually quite a bit of open source repository now that enable a lot of artificial intelligence algorithm that you can build on top of, and you can also share and contribute. We found that to be extremely collaborative and very helpful to accelerate that, because why bother to actually do supervised learning on speech recognition? Because if nothing else, the smart speaker market just totally, completely take off, and there's tremendous amount of algorithm you can actually take on. But think about yourself, with every of your company or your application, if you can actually enable a smart speaker natural language processing algorithm that is already proven by Echo, Dot, or Google Home, just take it. And all of a sudden, you feel like from a customer user interface perspective, you give another perspective, another interaction with your client that all of a sudden make you feel like you're really cool, that you're AI enabled. So the lessons, I think, what I felt we're learning will be determine a couple seconds of some application that you can actually determine whether you can teach a machine and develop your own algorithm. Do a good job in actually spending the time, maybe identifying some data scientists who can actually help you to develop a good training set, and then using your own internal company and your own experience in actually determining the test data set, then you can continue over time, be able to teach algorithms on determining whether certain things are working or not working from a failure and a defect perspective.
Okay, so it's possible to get hands-on and do stuff. Yes, Daniel.
I wanted to follow up on David's anecdote. So apparently that didn't go so good, but there is other examples, and one example which I think is quite interesting. There's I think it's an American company called Kaggle, or it's an organization that is doing these competitions with big data. So they have a question and they have a lot of data, and then you can compete on trying to create the best answers or the best model to answer those questions. And I remember they had a couple of years ago a competition which was based on basically this question. So if you are about to buy a used car, so what are you going to look at that used car to have a used car that has as few faults as possible? So if you're going to buy a used car, what you're actually going to look for if you want a good quality car? And of course you can think about a lot of things. Should it be I don't know, a German car? Should it have a special price on it, etc.? But the number one, the strongest correlation they actually found on this topic was basically that the best cars, which has the fewest faults of all, are orange cars. So you should buy an orange car. And there's probably some truth in that. The first question is, of course, why? It doesn't have to be true, that's the first thing, but it probably is. And the question is then is why? So why does orange cars are better than other cars? And I think the interesting thing here is you don't necessarily need to know the answer to that question. So I think we're moving from a world where you basically always had to know exactly how you could model the world, build up, a model and know every detail in that, to a model where you're using more of data-driven. It's more of answers that it's probably true, but you could also act on those.
I don't know that I
thoughts.
always agree with that, Daniel. Because look at the orange car example, right? So I suspect the reason that is because it's probably old people that buy orange cars and they don't drive them very much. But what if everyone in this room went and bought an orange car on the basis of what you said?
Yeah.
You
You
said,
can-
right,
you can
Daniel from
repaint it.
Microsoft say orange cars are more reliable. we'll go out and buy an orange car, and funnily enough, they're just as unreliable as they normally are, because actually we've inferred something from the machine model, which actually has got nothing to do with the fact that orange cars are more reliable. It's just that orange cars tend to be driven by old people. Now, as soon as we, as a young group, go away and buy orange cars, we're going to distort the numbers, and then suddenly orange cars become unreliable. And that may not matter in the context of orange cars, but sure as hell matters to me if I'm choosing one generator rather than another, right? Because that's going to be there for 15 years. So for me, I think that's an example. You provide an example, actually, of how you have to be more cautious of machine learning, of answers derived from machine learning, because but that's the same with any kind of statistical analysis. And I'm not even sure if that required machine learning, frankly. That just sounds like a stats analysis to me. But actually, that really kind of shows machine learning for what it is. It's stats. And you always have to be careful with stats, because if you make assumptions without really understanding what those underlying correlations are, you can be misled into buying an orange car.
Yes.
Well, I think we all agree orange cars
No,
are
I
horrible.
agree on that. And I think one good point that you're also bringing up is, of course, you're disturbing the system when you're when using.
But mostly you're going to use machine
of
learning for quite dynamic systems, right? 'Cause you didn't tend to model a system that's static using kind of any ML tools, because there's easier ways of doing it. So the systems that we're talking about are always going to be quite dynamic and have these complex interrelations. And that's why I think that people have to be so careful when a consultant says, and I know this isn't you guys, Matt, but there are other consultants who are out there who just say, yeah, we're going to come fix this, it's all fine. And actually, unless you have that real understanding of data centers and systems, are you going to make the right kind of recommendations? And if what you recommend is, guys, I can make this data center super efficient, we just turn off all the lights and you're not going to use any power, well, it's not really a kind of helpful recommendation to get from a machine learning model. So I agree with what you say. I think for some things it kind of is less important. I think you've got recommendation engines like Destiny from Amazon and stuff, and it probably doesn't matter too much if they recommend me a different washing machine than the one I want. But in the context of using machine learning to improve how we build and construct data centers, and these are assets with 25-year life cycles and customers who really care about them being on, yeah, for sure, I'm not going to make a change because the machine says do it, unless I understand why there's a benefit from
The only thing I'd add there is I think we've turned down more opportunities thus far than we've taken on.
Yeah.
Because I've tried, again, we've been very intentional about how we've built what we've built and why we've built it the way we have. And it fits in a lot of scenarios, and there's scenarios it doesn't fit in. And I think we have to be comfortable understanding and admitting when there's an opportunity for success and when a specific approach is probably not the right one to take.
Okay, yep. I thought you were going to say they build the orange cars on a Monday. Which
Yeah,
might be
well,
another
who
phase.
knows?
Yeah. So, but I want to ask now, really, because we've heard that it's a good idea to get hands-on. It's a good idea to make sure that the data is right and all that. I want to know what did the AI empire ever do for us? I want to know if if I'm running a bunch of data centers, what is it that AI can help me do? Can it make my data centers run more reliably or serve customers better?
Yes.
Or
Yes.
oh, okay, good, excellent. Shall I ask how?
So I can jump in. A couple of the things that we've tried to do is we've tried to build an agent or build a system that contributes meaningfully towards site reliability and uptime. And that's why we chose, on one hand, we chose the IT stack because there's a number of really interesting sort of ways to close the loop on using AI from a monitoring perspective, from a cluster health perspective, from a reliability perspective. To be able to understand why there's only two types of technology. Technology that has failed and technology that will fail. Okay? That's the bottom line. And so when you are building a system, understanding that reliability and uptime is of the utmost importance. And there's an institute built on the back of the need for uptime. We can build tools using the right techniques to contribute towards that. This is not a comment related to the AI replacing facility operators or humans or IT personnel that are operating there. I would say that using AI in a data center specifically for IT allows those site reliability engineers or whomever it is to operate what I would call at the top of their license, right? take away all the tasks that they don't need to be sifting through to find needles in haystacks, and let the AI agent, our agent is built to go find those issues, to detect them in advance, and to be able to actually close the loop on the control side of saying these are the actions that need to be taken, and automating those actions. And to David's point, we not only automate those actions, but we give reasoning as to why we did it. And that, I think, is incredibly important.
So, pressing you to give me a concrete example of something that that it might improve in a data center.
Sure. So I can use one example on the IT side and one on the energy side. On the IT side, let's think about a multi-tenant co-location environment for a data center. You've got the ability now through using an AI agent to automatically understand and predict when new clusters need to be spun up per any given client. When a specific, down to the node level or the server level, when something is predicted to fail or go down, we can automatically detect that in advance, and we can automatically shift processes from one server to the other. We can understand, according to the incoming demand between CPU and GPU-driven processes, what is the most efficient and cost-effective way to deliver this service. We can help organizations understand where they're overspending on computing resources and where they might be able to become more efficient. And then, of course, taking organizations from reactive to proactive in all of these areas as it relates to failure detection, anomaly detection, hardware-related things. On the energy side, the agent is embedded and talking to and sort of calculating continuously across about 37 different variables. These variables, some are environmental, some of them are attached directly to the machine itself. Of course, we track and control all the usual suspects within cooling and HVAC. Essentially, any component that is attached to an IoT sensor, the agent is able to understand and take actions. And so we are helping organizations continue to drive down PUE. We're helping organizations understand down to the row or the individual zone level where things can be where cooling and HVAC can be optimized.
So I think both those examples illustrate a really important point. You could do them. If you were just sitting there for long enough, right, you could crack out, if we get this inbound request, it's going to create this workflow, and this application is going to request this from this middleware, and that's going to require that much network bandwidth, and that's going to require all this stuff. So you can do it. And then in the data hall world, you know, we use, and I'll talk about the success we've had using machine learning to control our crack units and stuff and replace static pressure and temperature measurements. But the point is, you can do this stuff. You can grind it out. It just takes so long. So the machine learning is just providing a tool to kind of almost fudge those models. I don't want to say fudge. It provides very statistically accurate predictions of how a system will behave, but it's not deterministic, right? So if I build a finite state machine, I can understand exactly how my system will perform at all times, right? Matt's system will never be able to do that. But the point is, we stopped being able to build finite state machines for stuff when we were building parking meters 20 years ago, man. These systems are so complicated, you can't possibly do it. So what this does is provide a statistically testable method of building the complexity of those models and baking it into a machine learning one. And to give you, I think you wanted some real examples. So obviously the first project that we worked on doing machine learning in a data center, of course, is the one that's been most successful. And ever since then, we've spent way more money and not ever achieved anything like the success on it. And you know, so the first one was looking at how we optimize the performance of our crack units, right? So we have this very dynamic system in the data hall. We've got, you know, workloads moving up and down, customers throttling in and out, servers moving in and out. You know, it's a very dynamic environment, right? So we could run a CFD. We could run a computational fluid dynamics study every time something changed, right? Every time we lost half a watt of workload over here and we gained it over here, we run a CFD model. We could do that. And then we could use the data from that CFD to control our crack units. And it would probably take 2 years every time we wanted to make a change. But actually, as it turns out, you don't really need a detailed physics model to do that. What you can do is you can bake that statistical knowledge into a kind of automation engine. And it's exactly what we did. We installed this platform. It wasn't from Matt's, it was from someone else, Vigilant, I think. And we saw 10 points of PUE across our estate. I mean, you can't beat that for return on investment. And it wasn't simple, and all credit to Equinix's incredible operations and engineering team who had to retrofit all sorts of crazy devices to allow us to control all of this stuff. But what we saw is this incredible return on investment. And for customers, it's brilliant because not only is it delivering a more efficient data haul, but it's also allowing us to operate in failure scenarios much more efficiently. So we're delivering better availability for our customers, and we're saving polar bears. And all for a sensible, controlled investment. But again, it's a very specific use case, and I really kind of want to emphasize that point. If you can think about how you could do it, but you just think it would take a long time, that's probably the kind of problem that maybe you really should think about using some sort of machine learning technique for. That's definitely, it's not always going to be true, but if you find a problem that you think we could put two people in an office and give them a week and they could probably work out the actual answer, that probably is a flag that says to you that's the kind of category of problem you should be maybe thinking about whether you can use some sort of machine learning technique to automate.
Right. So it's a really, really exciting technology, and the stuff you give it is the stuff that would bore anybody out of their minds.
Yeah.
Okay, good. Anything, Daniel, does that ring bells with you?
Well, I don't have any deep knowledge on the topic, but I do know that. So I was visiting Microsoft Research not so long ago, and just the research area is, I think it's 1 out of 5 research areas at Microsoft that is really focusing on this topic, because there's an enormous amount of money to gain, as you said, if you do it right.
Mm-hmm. We perhaps should talk about the social thing because, there's one other point, a remark I was going to make, which is in the journalistic world where we get PR, I've noticed that everybody who does an old-fashioned DSIM solution, with maybe a couple of exceptions, a couple of decent, honest exceptions who still talk about what it is, they've added some intelligence here and there, and it's become an AI system.
DSIM is AI because that's an expert system, right? So if the temperature of the flow from the chiller exceeds 22 degrees, kick in another chiller, right? That's AI. That's perfectly valid AI. It's an expert system. Build your systems like that. Only go to something like deep learning or machine learning if you absolutely have to, because these systems are easy to understand. You've got, if so happens, do something else, right? And it has the beautiful benefit of being able to understand at all times exactly what the system will do in any particular consequence. So if you can do that, great. And you know what? Those DSIM companies are telling the truth. That is AI. Is it as exciting as something like deep learning, and does it give you the capabilities? Yeah, in different scenarios, for sure it does. There's nothing wrong with that approach to AI. It's perfectly valid. It's worked for years.
Okay. All future DCD supplements on DSIM will be renamed.
AI. I've probably just added a load of market value to those companies as well.
Fabulous, yes. Although that might make it harder to distinguish yourself at Carbon Relay.
I mean, again, we're not a DSIM solution. We want to be an intelligence layer that's compatible no matter what you're using. I think in that world, though, this I don't know if I'd call it expansion or shift towards DMAS is becoming very interesting, because it aligns with the whole the previous comments around how are you actually as an organization intelligently capturing the data that's being generated in your environment.
Sorry, DMAS.
DMAS. So you've got Schneider and Emerson Power and Enlight and other organizations sort of saying, look, what worked in DSIM was really fantastic, and it paved the way. If you think of DMAS as sort of the data lake meets DSIM, that's what this world is becoming. And I think what it's allowing organizations to do that understand their environment correctly is to look at the data that's being generated, depending on what type of operation you're running, of course, as an asset versus a potential liability, or this mountain of data that's unable to be understood, or whose value is unable to be captured, maybe at the degree that would keep you up at night. So.
Okay. Artificial intelligence as an answer to the skills crisis. maybe what I'm hearing is that that's a non-question. What AI should be doing is the stuff that people couldn't or wouldn't do.
No, I don't. So one of the great examples, and I love this one. Sometimes I marvel at the folks that run our sites. But one of the things that we tried to replicate with machine learning was, and I wonder how many people in the room will kind of acknowledge this. A lot of our engineers said, you know what, I can often tell whether something's about to break because it makes a funny noise or it smells. Does anyone in the room is this not just me, right? We've got data center people here who would agree with that. Yeah. At least one. Everyone else must be doing sales or something.
I saw it. Five heads nodding.
But you know what? When we asked that question at Equinix, a whole bunch of people said, I can just walk past the chiller. I'll tell you. Well, I'll tell you where that compressor's about to fail, right? So that's not magic, right? These guys aren't kind of sensing the thing. What they're doing is they are recognizing patterns that they've learned over the years, right? And those patterns are patterns of vibrations that translate into sound, and human beings are really good at spotting those patterns. Check out my blog. Pattern recognition is really important for humans. It stops you getting eaten by tigers. So what we found is that actually machines are really good at doing that too. And we don't want to replace those people. We don't need to replace those people, right? But we don't have, we
haven't got
can't
that many
scale
ears.
those people with our business linearly, right? We can't just keep finding all these people. And that's another topic for another panel, but we really urgently need more people in the industry. So this isn't about, for us anyway, replacing people. It's about how do we sustain our growth? And also, how do we make sure that Tony in Singapore has got access to Bob in San Francisco? And now Bob in San Francisco can't be walking past the chiller in Singapore, but can we translate Bob's knowledge to how a chiller performs in San Francisco? Is there commonalities with how it performs in Singapore? And what we discovered was that we could build systems that would detect those same vibrations. Now, the machine isn't going to go immediately, oh, that must be a compressor about to fail. But what can happen is we can get Tony to tell, I can't remember whose name it was now, I shouldn't have made these up. Tony or Bob, one of them anyway is the expert one. He's going to tag this now and say, oh, hang on a sec, there's something wrong with this chiller, and the machine has noticed the vibration signature has changed, right? So then he's going to go and do some work on it, right? He's going to go, that was a compressor failure. But the next thing he does is the magic piece. So what he then does is he tags that in our system. He says, this is a compressor failure. And now the machine goes, oh, okay, so I can see these normal vibrations. So when it goes wrong in Japan, we see that same sort of signature. Maybe not exactly because it's installed in a different room and maybe it's a bit noisy, but that's the great thing about machine learning. It can still recognize the pattern. So then we tell the engineer in Japan, hey, Bob has already solved this. Maybe it's not a compressor failure, but maybe the first thing you should look at is to see whether there's something wrong with the compressor. And actually, that's how we build our knowledge, right? That's how we augment our knowledge. So we don't see this as replacing these incredibly smart people that keep our data centers on. What we see this doing is just another great tool. You wouldn't go to a rack without, a multimeter and all these other things that you need. And we just think in the future, you're not going to go to a machine without these kind of tools that give you access to that knowledge. We want everyone at Equinix to have knowledge for everyone else at Equinix. And machine learning, and really importantly, the platform, because most people aren't data scientists, right? They don't want to do this stuff in MATLAB. I promise you, you don't want to do this in MATLAB. You want a nice web GUI. So having the combination of the machine learning smarts, the understanding of the infrastructure, the data scientists who can make all your horrible data nice again, and then a nice user interface which encourages your users to actually use these systems and tag stuff, it is really where you get that kind of magical intersection. But that's not about replacing people. I think I must have mentioned people, like at least Bob and Tony, 100 times in that. It's all about how we provide better tools for people, how we make their days safer, and ultimately how we deliver a better service to our customers at the end of the day. And that means keeping the lights on.
Daniel.
Yeah, I fully agree on that. And I think that there has been research for the last couple of years that's also showing that if you actually are using humans together with AI systems, you are gaining a lot of better quality. And the reason for that, there is a number of examples. For instance, like if you want to beat the best chess playing machines right now, you should have a chess playing machine plus a human. So you actually are not able to build technology that could beat, the combination of a human and a chess-playing machine. And the reason for that is that people and AI systems are good at different things. They are looking at things. People are learning stuff differently than a machine learning model is, basically. As a human, you don't have to look at 1,000 or 100,000 pictures of dogs and cats. You can learn that in another way. So it's another way of learning. And if you combine that together with machine learning, you getting a lot of better qualities. And I think what they have been seeing the last couple of years is that if you apply that, for instance, in healthcare, you have a radiologist and you are using machine learning to detect cancer tumors or other differences on pictures. The combination of having a radiologist and the AI system to do the investigation is normally so much stronger than just having a machine learning algorithm. So people are important.
The only thing I'd add there is it's kind of a combination of other comments, but this idea of providing the tools that allow folks in the data center to either write out or document in some way, shape, or form the actions that were taken and the results. To Susanna's point, ultimately down the road, that creates an enriched training set for your next model, right? And so if you can create this interaction that provides cohesive understanding of what the problem was and what the fix was, ultimately down the road, you're investing not only in your people and their ability to operate more efficiently and effectively, but you're investing in the future of what your machine learning capabilities will become.
Training's another really great one. And I think this isn't brought up enough. You know, you wouldn't get on an aeroplane, right, with a pilot who just flew it for the first time. You'd want to have him to have experience in a simulator and stuff, right? But we don't typically give our data center engineers access to like a theoretical data center and get them to start tweaking buttons and seeing how stuff breaks, right? But wouldn't it be really good if they did have experience of lots of failure scenarios? So one of the awesome things that you can do is you build these models to effectively predict PUE, and I probably don't have time to explain how they work today.
We don't. We've only got a couple of minutes
left. All right,
left.
I'll be very quick. But you can use those same models to replicate your data center in a training scenario. So then suddenly you can have a bloke outside the room start causing frequency issues on the incoming supplies. The guy starts seeing all the virtual lights lighting up in the right ways. You know, we're working with Microsoft. We're testing kind of AR systems to allow our people to actually stand in front of the physical device and go through the motions of the things that they would do. And we can simulate all that in software. So we can build these really accurate training simulations using exactly the same model that we're using to enhance the PUE.
Okay. Now, we haven't been heckled once, so I'm assuming we all did a good job. But are there burning questions in the audience? Because I think Zach will probably allow us time to take them if there are. There are none, are there? Okay, good. I'm going to take that as a vote of thanks. And is it time for us to be wrapping up, Zach?
It would be, yeah, just around about now.
Okay. I mean, my summary for this is that if I thought AI was about trying to create human-like thinking, it's failed, but in a way that's actually created something useful that complements us and is doing real work for us, both inside and we didn't talk much about outside data centers. Quick thoughts, Susanna?
Definitely, I am a proponent for incorporating artificial intelligence in our life going forward. You owe it to yourself, each of you, to actually improve your own skills, learn about the technology, what it can and cannot do for you, what it means for you in terms of how it conjures up emotions about how you react to it, because it's going to happen around you.
Yeah.
You're going to like some experiences, like maybe it's a smart speaker.
Yeah.
Some of them you may not like, and some of them you will never be able to accept because it's just too far your emotional boundary. But it's nothing genuinely relating to the technology is going to stop you. So I encourage each one of you to maybe read David's blog or go to some other area to at least take part in learning and immersing yourself into it to see what it really means for you and make it to be more personal for your job, for your personal life, and maybe for the generation to come, because it is going to happen around you. Many corporations or government are already incorporating artificial intelligence and deep learning around you, so you must well immerse yourself in it.
I'll be very quick. If your kids are studying law, medicine, unless it's surgery, because that's kind of hands-on, or taxi driving, probably I would recommend that they really consider a new job. I think people massively underestimate the serious and very speedy implications in what we would typically have considered careers that couldn't be done by machines. I think people in this room in 10 years' time will be very unusual that you'll have an actual accountant or a lawyer or anyone else do that stuff. It will all be automated.
Thank you, David.
Again, I would just say, really take the time up front investing in what are the set of problems I'm trying to solve, and therefore, what is the right approach? Is it within the field of AI, which approach needs to be taken? This is, very clearly, I think, in a lot of ways, a build or buy scenario. And so, as you're understanding your problems and therefore the necessary approach, the next conversation is, am I building this myself or am I buying this via a vendor or M&A or whatever it is? As a result of that decision, I think investing the time up front allows you to make progress quicker. The time to value will be shorter, and the investment hopefully will pay itself forward into something that's scalable with the dynamic environment that you're operating in.
Okay, and Daniel.
Yeah, I just finished up. Then I think we didn't, as you said, we didn't talk so much about the AI outside the data center, and I think that's also could be interesting to understand more about basically what kind of technology trends are impacting the use of data centers, because we are seeing a lot of new innovations outside the data center that needs a data center. But we're also seeing interesting innovations outside the data center that basically takes away the load from the data center. I'm talking about intelligent edge devices, and etc. So it's a kind of a complex world there for the next.
That's right. There are specialist AI chips that many of them are going to find their way into headsets and cars. And
Yeah, well, you mostly only execute you mostly do the training in a data center, and you actually just run your models there. So I don't think we're too concerned about the disappearance of load. Although that in itself is a different problem that we have to solve, the kind of variability and load of these machine learning platforms.
Right. So we'll all go and find out about this, and we'll all go and help solve those problems. Thank you to the panel for your contributions. I've learned a lot in this process. Thank you to the audience for your patience and engagement.